Yes,
Well,
we're
well,
good.
thank you very much, Mark, for inviting me to review this interesting topic again. Lately, mostly we've been seeing breakthrough infections. Has it to do with mutants, variants, or has it to do with the wearing off of the vaccination effect? So a lot of challenges ahead. I wanted to review what I read in the past 2 months. So most of the literature you'll see just a few days were published a few days ago or a few weeks ago, very, very recent. Traditionally, when we cite publications, we cite what year was published. What year is a long time. So here it goes by month and by day. So every reference I refer to will have a date. So you can put that into perspective, how the knowledge base has been evolving. Okay, before we talk more about vaccination, what is vaccination for? The vaccination is to build up the community herd immunity without getting sick. So where is herd community? How far away we are from that? And as we're thinking about that, I did not have any data, and then it was just published 2 days ago. Fantastic data when it shows up in my email bin from JAMA. The title was US Infection and Vaccination Induced SARS-CoV-2 Seroprevalence, people who have positive antibodies, reflecting that they have built up immunity. What percentage of people in our community, in our country, already have antibody against the virus? It is easier to know how many people, what percentage we have vaccinated, but we actually don't know how many people got infected and naturally acquired some degree of immunity. So this was a great idea, started out from academic research and expanded and sponsored now by CDC. So across the nation, many blood banks joined this effort. On an average, between last June and this May, about 140,000 blood donation specimens was collected. So over a period of 10 months, about 1.4 million specimens were collected. Here, they're talking about specimen, they're not talking about unique persons, because each person may go back to donate blood every 2 months. So over 10 months, that person might have been counted 3 times. So they're counting specimens. As I was thinking, why did not count person instead of counting specimens? Because if you count person, which time point do you count? Last March, this July? Because at different time point, this person might be seronegative and change to seropositive. So I think counting specimen is a more scientific way to track this data. By the end of May this year, having a hard time getting my mouse to work. Sorry, let me get my. So by the end of May, the spike protein antibody prevalence is now about 80%. So in this blood bank donation donors between age 16 and 65, 83% by the end of May already have antibody. So that's pretty high, as we may recall, many experts were calling about if the population has 75% or 80% immunity, that's herd immunity, it would put a stop to the pandemic. That is not happening. Why? Because the blood bank donors did not include the youngsters. Children were not vaccinated. So the overall immunity is still not that high. If the spike protein is positive, how do you know it's the vaccination or it's the infection? So the nucleocapsid antibody will be only available or generated by lateral infection. It is not present in a vaccine. So if you have a spike protein antibody that's positive, and then you do a secondary nucleocapsid antibody test, and that will separate out the people who got immunity from natural infection. So about 20% of the population, in that population, got the natural immunity from natural infection, and total combined is about 83%. So that's a cross-sectional study. That's where we are. I wanted to talk about the successes and challenges here. What's the success? A number of vaccines have been developed using different technologies, the new technology, traditional technology, and they're highly effective. We're going to compare the efficacy, and the side effect profile has been fairly favorable. We're going to review those studies. And then we're going to talk about special populations. There are people who are pregnant, there are people who are breastfeeding, there are people who got cancer, there are people who have solid organ transplant recipients, there are people who are on immune suppressive drugs because of rheumatoid arthritis or Crohn's disease, and there are people who were already infected. And what do you do with those? So we're going to talk about those special populations. And we're going to talk about the challenges. The challenges if the lockdown's being lifted, and we got some governors like in Florida who is fighting against mandates. And there's population compliance fatigue that gets sick and tired of staying at home. They wanted to go out, and all this behavior will increase the risk of infection. And there's the waning vaccine protection. As you got the vaccination, and then the protection is not going to last forever, just like the flu vaccination. You get that once a year. So do we know how long the vaccine effect is going to last? When do we get the booster shot, and what do we get? And can we mix and match? You got the Chinese vaccine before, I got the Johnson & Johnson vaccine before. I changed my mind. I'm going to use the mRNA vaccine. Is that okay? And what's going to happen? And what about the mutants? They're constantly evolving, constantly popping up. Are they evading or escaping the protection by vaccines and antibody therapy? And what about the unvaccinated children returning to school? So all these challenges and unanswered questions, I'll review as much as I can find in the literature. So let's review the milestones, the major milestones in vaccine development. It's amazing as you look back. The first vaccine for human use was developed so many years ago, 18th century, smallpox. People realized the people who milk the cow don't get smallpox, and that's how they discovered the smallpox vaccine. And over the years, as you can see, as time goes by, every century or half a century, we're producing more vaccines. And then the newest member is the SARS-CoV-2 vaccine. So science and technology is improving, but if you break down the strategies, how to make vaccines, you can look at them in a number of ways. You give the pathogen as a whole organ, either virus or bacteria, and you have to kill the virus first. So that's the inactivated vaccines. The successful stories are hepatitis A, which is lifelong immunity. Once you give somebody 2 shots of hepatitis A, they're immune for life. Flu shots, which unfortunately only last for a year. Polio is lifelong. Rabies, and I put shots here because the nasal flu shots is attenuated live vaccine. The oral polio shot, the vaccine is live attenuated. Only the shots are inactivated. Then you have the live attenuated vaccine, meaning that you reduce the infection risk by killing the virus partially. And these are measles, mumps, rubella, MMR, and rotavirus, smallpox, chickenpox, yellow fever. So plenty of examples of attenuated live vaccines. And these first 2 approaches will give you the whole pathogen, the whole organ. You're not picking and choosing which subcomponent. The next is recombinant or subunits. So you can pick a component of the pathogen, such as, I'm a hepatologist and gastroenterologist, I can give the example of hepatitis B. Instead of giving the whole hepatitis B virus as the vaccine, you use the surface antigen protein only, because the core antigen doesn't produce any protective antibody. The E antigen does not produce any protective antibody. It's the surface antigen. So you use a component, and recombinant hepatitis B vaccine has been used for 30 years. It's very safe. It's given to babies immediately after birth. And instead of, so the next one is, instead of the pathogen themselves, you're giving the product of the pathogen, the toxins like diphtheria, tetanus shot, you're giving the toxin produced by the bacteria as a vaccine. And I'm thinking about the same thing as Clostridium difficile. it's the toxin that produces the disease. It would be fantastic if somebody develops a vaccine against C. diff toxins, but it's not there yet. So that's the traditional approach for vaccine production. And there are 3 Chinese vaccines that are produced by using inactivated vaccine. There's 1 US company producing recombinant COVID-19 vaccine. And then the rest were the brand new technology. One is the messenger RNA vaccine. It's brand new, never been used in human studies, but actually the technology has been in development for cancer treatment for many years. So there's basis for moving forward from that. And then the viral vector, such as adenovirus vaccine, has never been used in humans for infectious disease, but that's basically the same technology used for gene therapy. So all these new technology is not brand new. It's being developed in other fields for many years, and that helped the leapfrog the current mature product on the market. So if you look at the WHO collection of the number of vaccines in clinical trials or in clinical use already by the end of August, by August 27th, there are about 112 of them. The most common vaccine candidates actually is protein subunits, and most of them are probably recombinant. And of course, we're using a messenger RNA already, and Johnson & Johnson is a viral vector, non-replicating adenovirus-based the vaccine. So you can imagine there are so many candidates coming out, and what's dominating the marketplace right now is the 2 messenger RNA vaccines. That seems to be the safest and the most effective. Here is an older article from JAMA, which is still true. This nice table, I borrowed it to display all the vaccines we're going to be talking about today. One thing I wanted to point out that often people ask, what's the difference between the Moderna and the Pfizer vaccines? They both are messenger RNAs coding the full-length spike protein. So they're essentially identical. They have some modifications and to make the RNA more stable. So they mutated it, manually mutated it to some degree, but majority is identical. But the dosage is very different. The Moderna dosage is 100 micrograms, and the Pfizer dosage is 30. So the Moderna gives you 3 times more messenger RNA as compared to the Pfizer. That might explain for some of the side effects difference. We'll talk about that more later. And here is the FDA approval status. On December 11th, the Pfizer vaccine was approved under emergency use authorization condition for 16-year-old and above. And 1 week later, on December the 18th, Moderna vaccine was approved, but there was an age difference. This was age 18. Perhaps the Moderna dosage was a little higher. They didn't want to give it to kids. And then the next February, Janssen vaccine was approved. Again, it was for 18. So only the Pfizer was the first go around, it was 16. And on May 10th, Pfizer was approved to go down to age 12 and 15 under emergency use. And then August the 23rd, less than a month ago, it was approved under regular approval for 16-year-old and above, but for 12, it's still emergency use condition. Pfizer gave the vaccine a new name. It's called Comirnaty. It's difficult to pronounce. I initially called it Comirnaty, but I heard people calling it Comirnaty. I don't know what that means. It was a tongue twister. So let's review some of the vaccine clinical trial data. And then I'll review the vaccine data outside clinical trials in real life. You probably didn't know, actually, Pfizer had 2 mRNA messenger RNA vaccine candidates in its phase 1 and phase 2 clinical trial published in the New England Journal of Medicine in October. They were the BNT is the German company that produces the vaccine, and then 162B1 and then B2. B1 was a receptor binding domain only. So it's not the entire full length of the spike protein, only the receptor binding domain, because it's a short peptide. The immunogenicity is probably small. It's not strong. So they used the trimer. They triplicated it to make a longer full protein. And B2 is at the full length spike protein. In their phase 1 and phase 2 clinical trials, the efficacy were pretty much identical. What's different is the side effect profile. So for B1, the side effect is more common and more severe. When it's blue and gray, it's more severe, and as compared to B2. So they decided to keep B2 in phase 3 clinical trial, which was published 2 months later on December the 10th in the New England Journal of Medicine. So they were moving really, really fast. The overall vaccine efficacy is 95%, and there are some ratio analysis. What's interesting is they seem to work well in the Black and white population, perhaps not in Asians. And it was discussed about, but the sample size was small and that it was difficult to draw a conclusion. But that kind of planted some seeds in my mind. Perhaps the Pfizer is not so good for the for us Asian population, and we needed a higher dose like in Moderna. And also in Brazil, the efficacy was lower. As you know, Brazil has a different variant there. I think it's Gamma. It's from Brazil. So perhaps this vaccine is not as good for Gamma. That's why in Brazil there was lower efficacy shown there. And then Moderna data was published about 2 weeks later, 20 days later, in the same journal, New England Journal of Medicine. Overall, the efficacy is almost identical, 94%. So even though Moderna uses 3 times more messenger RNA in the vaccine, but it did not produce 3 times better efficacy up front. And then for other color, for Asian, and the data seems to be the same, perhaps even better. So for a while we were contemplating maybe we Asians should get Moderna instead of Pfizer, but this is very difficult to conclude based on the number of Asian populations included in this study. So that's the 2 messenger RNA data. What about the 3rd vaccine approved in the US? That is the Johnson & Johnson vaccine. And this is a adenovirus based, and this is a single dose vaccine, not double dose like the other ones are. As you can see, this is a single dose. So they compared 14 days later and 28 days later instead of after first shot or second shot. The efficacy is about the same before and after, about 60-some%, and in protecting infection. But for severe critical infection, the protection is about 85% after 25 days. So clearly, the adenovirus-based vaccine seems to be less effective as compared to the messenger RNA. And is this true also for the AstraZeneca vaccine that was developed together with Oxford University? And very similar. So the AstraZeneca vaccine is based on the same technology using adenovirus as the vector. They chose a different, there's so many different adenovirus, they obviously chose a different one, but the final result is very similar. The efficacy is about 70%. So 60 to 70%. Their trial data is kind of messy and the sample size is smaller. So I never had as good a confidence in the AstraZeneca just based on their limited data. And I said messy because they messed up their trial. Some patients accidentally received half dose, so they called it low dose, and instead of the standard dose. What's interesting is in the patient subjects who received the half dose, low dose, actually gave a better protection, 90%. I'm pretty sure it's a sample size variation, but the whole trial data was difficult to fully understand and interpret. Any other adenovirus-based vaccines that are published? There are some Chinese ones, but I have not seen a phase 3 clinical trial. There's the Russian vaccine that is also based on a adenovirus vector. This is a phase 3 clinical trial, but it's an interim analysis. They only show data after the first dose, and it was published in Lancet in February, but still I could not find the second dose data. I don't see any follow-up publication yet. Maybe I missed it. Maybe they just have trouble producing the data. They claim that their vaccination efficacy is 91%. This is a whole lot better than the other two adenovirus. So I don't completely believe the data because it's not reproducible with the other two. And we don't have to make any decision. This one is not being used in China and this one is not being used in the US. So it's just for comparison purposes. I brought it up here. And what about the recombinant spike protein vaccine? This one is produced by the US company, and the phase 3 clinical trial data was published in June. So I'm kind of expecting this vaccine to be approved. The overall efficacy is 89%. Most of the trials sites were in the UK, but some US sites were selected as well. I'm excited about this not because this is more efficacious, because this is more traditionally produced. People probably have more confidence. You know, there are a lot of people who are concerned about the messenger RNA and the viral adenovirus vector because they're such a new technology and they don't have long-term data for 20, 30 years. But this vaccine technology has been used for hepatitis B forever. It's been proven very, very safe. It's been given to newborn babies. So I'm hoping if this one is proved, perhaps those vaccine concerned population will be willing to take this one. Taking something is better than nothing. So with that approach, I am hoping FDA will prove this quickly. Just as I was hoping. A few days ago, on August the 30th, I read this news. The Novavax, which is the company that produces the recombinant COVID-19 vaccine, now received CDC approval to say if you were a US participant, you received this vaccine 2 weeks after the vaccination, you are considered fully vaccinated. So in a way, they already proved it, but not approved enough for the general public use. But I'm just thinking it's getting close. Okay, so let's talk about, because I think most of our audience are Chinese and we have ties in China and we wanted to see what the Chinese vaccines are doing. So there's a company called Sinopharm, I guess the Chinese name is Guoyao Jituan. It produces two inactivated vaccines, viral vaccines. One is called WAVE-04 and the other one is H02. What does it mean? It was taken from the virus grown out of two patients at a hospital in Wuhan. It's called Jinyintan. I guess it's Jinyintan Yuan. I was not familiar with this hospital. So two patients, in case there are different species, and the efficacy came out to be very similar, about 72% for one strain and 78% for the other for symptomatic infection. Prevention of severe cases was 100%, and the sample size was pretty large, 12,000 and 12,000 each. So it's pretty believable data, and average overall protection or efficacy is about 60 to 73%. So I can see that this inactivated vaccine approach seems to have produced an efficacy very similar to that of the adenovirus vaccines produced by AstraZeneca and Janssen & Janssen. There's another Chinese company that produced a third inactive vaccine, but I did not see any clinical trials. I have some real life data to show you later. Okay, so let's look at the real life data after the clinical trials, after it's been used in the population. What has been going on? And this was published in the CDC publication called the Morbidity and Mortality Weekly Report on August the 24th, regarding infection and hospitalization in people who actually received the vaccine, as compared to people who did not receive the vaccine. So infection in fully vaccinated was about 10,000. Infection on unvaccinated people were 30,000. And 55 of the population, 55% used the Pfizer and 28 used the Moderna, and Janssen was about 16%. There were some earlier reports saying people who got vaccinated, they can still have breakthrough infection, but their CT PCR cycle threshold values are higher, meaning that they have a lower viral load. But according to this CDC publication from LA County, the viral concentration in vaccinated and unvaccinated are pretty much similar across. So there's not a whole lot of difference in terms of viral load. And this same publication, how do we put this breakthrough infection into perspective? It was plotted out over time and the number of cases over time. So for infection rates, people who were vaccinated is 5 times less likely to get infected as compared to people who were unvaccinated. They're up there. So the difference is a 5-fold difference. But how sick do they get? The difference is 30 times different. If you're not vaccinated, you're 30 times more likely to get hospitalized as compared to people who are vaccinated. So even if the vaccination does not prevent you from getting infection completely, but when you get infected, you're 30 times less likely to be hospitalized because your disease will be milder, not as severe. And that we have observed in our state, in many different hospitals across the nation. At our hospital system, it's about 95% of all patients hospitalized about unvaccinated. And vaccinated people only about 5%. And most people in the ICU are not vaccinated. So the vaccination does help, even if you get the disease. All right, so that's the effectiveness, how it's protecting. Now, oftentimes we talked about, and friends will ask me, Dr. Mu, and you read a lot about this COVID-19 and vaccine articles, and what do you think between the Pfizer vaccine and the Moderna vaccine, which one should I get? And my answer has always been they're pretty much identical, the same full-length coding for the spike protein sequence, RNA sequence. The difference is dosage. Just you get more, you pay with more side effects, you get more antibody or something. For the first time, there was a head-to-head comparison in real life. The study was published on August the 30th, only 4 or 5 days ago. It was from Belgium. It was published in JAMA. So they look at all participants. 688 people had Moderna vaccine and 959 people had Pfizer vaccine. They plotted out the IgG antibody titer on the y-axis, and please pay attention to the y-axis. It's a log phase, so each big square is 10 times different. So it squeezes, condenses the difference together. And then there is a difference, as you can see. On the left panel is the Moderna vaccine. It's producing higher level of antibody. On the right side is Pfizer. It is lower. The difference from the chart, you would think it's very small, but it's huge actually, because we talked about this is a log phase scale. The Moderna produced 3,836 on average units per mil, and the Pfizer's only 1,444 units per mil. And the antibody titer, the difference is 2.6% or 260% difference, huge difference. And here they look at people who were previously not infected and people who were previously infected. It looks like the difference were not as obvious if you were previously infected. You got the 2-dose series as if you got 3, so that they evens out the difference. So as if you've never been infected by COVID-19 before, perhaps you would choose Moderna to gain a higher level of antibody production. So if you're Asian, you consider Moderna. If you've never been vaccinated, if you've never been infected before, you will probably consider Moderna to get a higher antibody level. So that's one study. Without seeing a second study supporting the first finding, I can never feel comfortable to believe that data. So it makes me always feel comfortable to see a second study. The second study only came 3 days later, published in JAMA. It came from University of Virginia. It's not as big a sample size. So what they showed here is the difference of Moderna and the Pfizer is after first dose, the difference is 3.2-fold higher. And after second dose, the difference is 1.48 times higher. So the pattern is there. The Moderna vaccine produces higher antibody titer as compared to the Pfizer, which makes sense because the Moderna gives you 3 times more dosage. And that's the take-home message. So I'm going to skip all the details of these charts. And so here compares here is the data I was referring to that shows the mean viral load was 40% lower in partial fully vaccinated people in this study. But again, this was not verified by the real-life data from Los Angeles County. I think that's the main point I was going to show you. As much as we talked about the difference of clinical trials, we said, okay, Moderna gives you 3 times higher dose and gives you 2.6 times higher antibody titer, but yet their protection is about the same, 95%, 94%. So what's the point of getting a higher dose, a higher antibody titer? There's almost no point. But you have to remember, those phase 3 clinical trials were done right after the patient received the injection. So perhaps above a certain threshold, there's no difference, whether it's 1,000 or 3,000. But if you drop below a certain level, and then you'll see the difference, that is, maybe the Moderna vaccine will last longer because they start out at a higher titer. As you go into 2 months, 3 months, 6, 7 months, you'll see the difference. Well, this study was conducted by Mayo Clinic. It was published in medRxiv in the beginning of last month. It shows for infection control by July, it is showing that the Pfizer vaccine effectiveness is dropping more rapidly as compared to the Moderna. And as far as protection against hospitalization are still similar, but still the Moderna vaccine performed better in later months. And of course, the factors are very complicated. There's variants, there's lockdown lifting, but overall, I think the data is fairly convincing that Moderna has the advantage of higher dose, higher antibody titer, and a more lasting protection effect from the real life data. And I mentioned earlier there was a third Chinese inactivated vaccine. They did not have a clinical trial that I can find, but I did find real life data. This was published in July in the New England Journal of Medicine. And there was almost 10 million people in a Latin America country, and 5 million control and 4 million 2-dose vaccination. And their efficacy was about 60, 80, 90%, depending on which parameter you're using. Protection against ICU admission is 90%. Protection against death is 86%. Protection against hospitalization is 86%. Protection against just COVID-19 infection is 60%. So looks like the inactivated vaccine, the third one from China, also shows a similar efficacy, that is 60 to 70% for infection protection, very similar to the adenovirus vaccine. Now, the other part of the vaccines is safety. We talked about efficacy. We talked about how long it's going to last. And what about side effects? There's so many studies. I didn't want to go through each one of them in detail, but there was a very good article published on August the 25th. So it's about a week ago in the New England Journal of Medicine. It came from Israel. They have a control group and a vaccinated group, each almost 900,000 person. So myocarditis is more common in mRNA messenger RNA vaccinated people. How much more common? It's about 3.2 times more common as compared to the control group. Lymphadenopathy, lymph nodes swelling, is 2.4 times more common. Why is the lymphadenopathy more is of interest and problematic? So say if somebody got breast cancer and then all of a sudden they found swollen lymph nodes in their armpit on the same side of their cancer. Oops, is this cancer recurrence, metastasis, or this is vaccine induced? And you can't differentiate that by doing a PET CT scan because the inflammation will light up under PET CT2. You end up doing a biopsy. So one has to keep in mind this possibility and not to overinterpret that or not to dismiss it as cancer metastasis. And then what's interesting is appendicitis and herpes is slightly increased, but not by much. But to put everything into perspective, that's the beauty of this study, is like the myocarditis. Yes, it's threefold higher in a vaccinated group as compared to the control. But what about comparing that to the people who got COVID-19 infection? The yellow bar is COVID-19 infected people. They're 10 times more likely to get myocarditis. So it's much worse to get the COVID-19 infection as compared to the vaccine. So everything has to be put into perspective so you understand your risk. All right, so let's talk about the special populations, which we alluded to earlier: the adolescent, the children, the pregnant, lactating, breastfeeding women. And then we'll talk about people who have SARS. Remember SARS 20 years ago? Fadia. And then the COVID-19 infected people, what happens when they get vaccination, and what happens to the cancer patients who get vaccinated, what happens to people who have inflammatory bowel disease. As a gastroenterologist, that's something I pay attention to, and what happens to the organ transplant recipients. So the adolescent study was actually the one I could find was a Moderna study. It was published in August, about a month ago, in the New England Journal of Medicine, and they found the safety and efficacy profile were very similar between age 12 to 15 and 16 to 17 age group. So what's interesting is it's the Moderna vaccine that published the data in the New England Journal of Medicine, but yet it's the Pfizer vaccine that got FDA approval to go down to age 12. So perhaps this vaccine at a higher dose is giving the regulators some trepidation to give to kids. What about lactating women, breastfeeding women? This is an interesting study that looked at antibody produced by the vaccine in the blood, in a serum, that's the orange color, and in the breast milk to see where the antibody will go. So that time point 1, that's 2 weeks after the first dose of a Pfizer vaccine. There was some antibody, but almost nothing detectable in the milk. But 2 weeks after the second dose and 4 weeks after the second dose, almost all breast milk will have detectable level of protective antibody. The antibody level is about 1% of that of the serum. So if a pregnant woman got the vaccination, and a woman will be able to produce antibody, and it will come out in the milk. Perhaps the milk can protect the baby, and it's fascinating data. What about safety in pregnant women? And this is actually a University of Washington system data. It was just published about 2 weeks ago in JAMA. Fairly large sample size. Pregnant women, almost 8,000. Breastfeeding women, almost 7,000. And then there was another 3,000 planning to get pregnant. The bottom line is the Pfizer vaccine produced a lower level of side effects of fatigue, neuralgia, headaches, chills, and fever as compared to the Moderna. But overall, the safety profile is very much similar of the pregnant, lactating, and people who are not pregnant. So the safety profile is quite good. And this article specifically compared, did some sub-analysis of the clinical trials when people who had accidental pregnancy. They joined the Moderna and the Pfizer vaccines. They were not planning to have pregnancy, and oops, they got pregnant. And then they followed them to see what happened to them. So in the Pfizer vaccination group, control group, there were 12 people who got accidentally pregnant, and in a vaccine group, 12 people. And there was no miscarriage in the vaccine group. And there was 8% miscarriage. So there's no increased risk of miscarriage or spontaneous abortion. Moderna, very much the same. Janssen, similar. One of them was ectopic pregnancy, Gongwaizun. And AstraZeneca data is kind of messy, but still, none of them showed any higher risk of miscarriage in the vaccinated group among all 3 types of vaccinations. So this is the next very, very unique and exciting article that I read. I always wondered what happens to those people who got SARS 20 years ago, right? They got Fadian 20 years ago. Are they less likely to get sick? Are they going to produce antibody more quickly? And what's going to happen? I never saw any follow-up study. I would imagine Dong Lansan or somebody in China must have a collection of those patients. But very interestingly, I saw 0 data coming out that I can find. But this one came from Singapore, and it's a vaccination data. They collected 10 specimens from 10 survivors who survived the 2002 SARS infection. They collected their serum sample 10 years later in 2012 and 20 years later in 2020, and now in this study. What they showed is for people who had previous SARS-CoV-1 infection and got vaccinated, and this time they're going to produce double positive antibody. They're going to produce an antibody not only against SARS-CoV-2, the current vaccine, but also they're going to produce antibody against the original SARS-CoV-1. And when this data was published, Science magazine wrote an editorial on the same day that caused COVID-19 vaccines may trigger super immunity in people who had SARS-CoV-1 infection many years ago. And this is fascinating. I'm thinking about they're producing this kind of super antibody, super protection. Does that mean if we do sequential vaccination, if one can develop SARS-CoV-1 vaccine, give that shot first, and then give the current SARS-CoV-2 vaccine, boom, we're going to be immune against the whole class of virus, in that class, coronavirus. That's just my speculation. That's why I got so excited by this little study. And then perhaps that's why New England Journal of Medicine accepted this study for publication. So, and let's look at the people who already got SARS-CoV-2 infection. We're talking about SARS-CoV-1 infection. Now we're talking about SARS-CoV-2 infection. So they already got COVID-19 infection. What happens when you give them vaccination? Why do we still need to give them vaccination? Like I said, I always wanted to find 2 studies that are consistent to believe the findings. So here we go, we have two studies. On the left panel is a study published in Nature Medicine back in April. On the right panel is a study published in JAMA just a month ago. Their findings are almost identical. So at baseline, before the vaccinations, the green ones were people who never had infection before, so their antibody is undetectable, very low. And then the purple ones were people who had COVID-19 infection, so they had some level of antibody, but not very high. When you give them one dose of injection, the people who were infected before, they have a much higher antibody production. The people who never got infected before also increased the antibody level, but still lower. But after the second dose, they became equal. This tells you almost like people who had the infection before, it serves as one dose of vaccination. You give one additional dose, you're just as good as people who got 2 doses in injection. And if you give the 2 doses, the second dose injection, you don't get any additional benefit because the antibody level is about the same. And the second study pretty much found the same answer. So I'm not going to go into the details anymore. One other point I want to make is about the people who had COVID-19 infection when they get the vaccination is when they do, they get 4.59 times more likelihood to have significant side effects from the infection, from the injection. But when they do the second dose, they're not any more likely to get the side effects, just the first shot. Very interesting. And this was Johns Hopkins data published in JAMA as well about 2 weeks ago. So let's talk about the cancer patient population. We're talking about special populations. When you give them a vaccination, what happens to them? This is a second of a series of analysis. So they did one previous analysis and current analysis. The previous analysis was about 1 month after vaccine injection. The current analysis is about 4 months after the injection. So what they show is for the cancer patient under treatment, they produce a much lower antibody titer as compared to the control. How much lower? The average control person will produce 3.7 times more antibody titer compared to the cancer patients under treatment at 1 month. At 4 months, the difference is 2.9-fold. So the ratio is it's persisting. And a cancer patient under treatment, they don't seem to produce as much protective antibody. One thing I paid attention to is, well, cancer treatment, there's so many different kinds of cancer treatment. There are chemotherapy, there is radiation, there is biological therapy. What about immunotherapy? Immunotherapy is supposed to boost your immune system. You're supposed to produce more immune response, even though the immunotherapy for cancer is mostly cellular T-cell response, not humoral. I would expect the people to produce more antibody in that regard. But actually, they did include a lot of cancer patients on the immunotherapy, either as a monotherapy or combination therapy, that somehow they still produce lower antibody. So here, perhaps the underlying cancer is compromising their immune system. Quite interesting point is the immunotherapy part. And so what about the solid organ transplant patients? This data was published again about 2 weeks ago in the New England Journal of Medicine. Before any vaccination, there was no detectable antibody as expected. Before the second dose, meaning after the first dose, very little antibody production. Before the third dose, meaning after the full 2-dose shots, only about 40% of organ transplant patients had protective antibody. 60% of them did not produce protective antibody at all. And then they have to give a third dose. So a third dose injection in this patient population is not to extend the duration of the antibody protection. It's basically to make sure you respond to begin with. So this group is really the most problematic. And here is a study published in July in JAMA in the kidney transplant patients. After a third dose injection, still a large number of patients don't produce any antibody at all. So organ transplant patients need to be really, really careful and protect themselves and be protected when they go to the hospital. Because a good portion of them don't produce, the vaccines just don't work. What about the Crohn's disease patients on the right side versus ulcerative colitis? And if there are gastroenterologists in the audience, so they might be interested in this. For the general public, probably not a big deal. So what's interesting here is Crohn's disease patients after vaccination tend to have a higher rate of breakthrough infection as compared to ulcerative colitis. My suspicion is not so much a difference in between these two diseases. Perhaps there are more Crohn's disease patients on higher doses of immune suppressive therapy. So this is a final summary slide I borrowed from CDC. It shows for cancer patients, the differentiated solid tumor cancer and hematological cancer. So the darker blues are hematological cancer. It looks like hematological cancer tend to have more problems of vaccines not working as compared to solid tumor cancers. Hemodialysis, not too bad. The organ transplant people are the worst. Their antibodies are, many of them, undetectable, even if they are, they're very low. And immune suppressive therapy, like a Crohn's disease patient, is variable depending on how many drugs you're treating the patients with. Okay, so let's switch gear to the breakthrough infection. Most of us probably in the audience are already vaccinated, and what we are concerned about or interested in most will be how much breakthrough infection we may be at risk. This is a complicated topic because breakthrough infection has to do with the population acceptance of the vaccine, of compliance of lockdown measures, political misinformation influences, socioeconomical inequalities. People who have lower income, they have to travel by bus and more crowded place. They often have multifamily living environment, and then you have the emerging viral mutants, variants, and also your antibody protection is waning off over time. This was a UCSD data, which is very worrisome. They talked about resurgence of COVID-19 infection in a highly vaccinated healthcare system at University of California in San Diego. I worked there before, so I feel dearly about that place. Their vaccination rate by the end of July is as high as 83%, but yet by July, 75% of all infection happened in that place are in people who were vaccinated. Of course, when you talk about what percentage of your patients are vaccinated can be very misleading to scare you. So say, I'm gonna give you one extreme example. If 100% of the population is vaccinated, then 100% of the infected will be vaccinated. That sounds scary, even if it's just one patient got infected. So the percentage of vaccinated people who are in the mix of disease does not tell you the whole story. And their final calculation is throughout the months from March, April, May, and June, the vaccination protection efficacy is still in the 90s, 93, 94%. But in July, it dropped down to 65%. What's the reason? Why in one single month, the vaccine just seems to be working as well anymore? So they did some analysis that put everything into perspective. One is in June, the California mask mandate ended. So they have more exposures in the community to others. And then perhaps the immune protection is wearing off over time. And then there's also the Delta dominance. The orange color is Delta. Since June, it's pretty much 99% Delta variant. And then, of course, there's the political regulatory changes of mask mandate being terminated. So let's talk about mutation and variant, because that's a major factor we have to consider when we talk about breakthrough infection. Is the virus smart enough to mutate and the antibody is not protecting them against them anymore? But before we talked about the variants, I wanted to point out the difference between mutation and the variants. What's the difference? You know, we're talking about mutations, and sometimes we're talking about variant, and we used to talk about, in my previous talks last year, I talked about a very important mutation. It's called D614G in a spike protein amino acid position 614. The amino acid changed from aspartic acid to glycine, from D to G. And this switch happened between February and May of 2020, a year ago. So the new mutation came in and wiped out everything. But now, why are we not talking about it anymore? Is this not a variant? Well, let me explain. So a variant is typically caused by at least 20 mutations or so. So a single mutation oftentimes does not produce a variant. A variant is a combination of mutations. And all these current variants, actually, most of them still contain the same mutation. And they tackle different parts of the spike protein, either in the receptor binding domain, the N-terminal, or the furin cleavage site. And of course, we're all familiar with these variants. Alpha came from UK, Beta came from South Africa, and then Delta is the most recent one from India. In early July, New England Journal of Medicine had a special report that talked about the vaccines and the variants, which is a very nice table. As you can see, the D614 mutation point is present in alpha, but still changed to G, and it's in beta in South Africa. So it's still there. It's being bundled, packaged into all these variants. And gamma, which is Brazil, and it's G. What's interesting is our current dominant 99% of the variant in our area is Delta. Delta also has D614 amino acid mutation, but it did not mutate to glycine. It mutated to arginine. So this is very unique. And Kappa, which is a cousin of Delta, and it goes to the regular G mutation. So it's kind of interesting. The D614G in Delta became D614R, and that's one unique difference. Here is a WHO table that shows variants of concern. These are the things that has enough characteristic change, either that might evade the vaccine, or they might be more infectious or more virulent and make people sicker. So alpha, beta, gamma, and delta are the four currently under the classification of concern, and they have a bunch that's called of interest that is being watched. And the most recent addition of variants of interest is mu. It was just listed a few days ago. I remember I was working that day, and I got quite a few text messages from my colleagues, and they say, Jim, did you notice that they just named something after you? So I'm the new villain now. I don't know much about this new variant. It's listed as interest, and it's not highly prevalent in the US, but it actually started in January in Colombia, in South America. So what about the variants in our states? This came from Washington State Department of Health website as of August the 26th. The Alpha, the UK variant, invaded our state in January. Every month we're getting a new one. And February, we got Beta, the South Africa one, and then Gamma came in March this year, and then Delta came in April, and ever since then, it took off. I'll show you the graph from our State Department of Health website. The orange color is Delta. Ever since June, it's been predominant, and by July and August, it's almost 100%. Everything that's been sequenced turned out to be the Delta variant. So that's what we have now. So there are so many implications of the variants that I'm not going to talk to. I'm only going to focus on if these variants is going to cause immune evasion or escape from antibody protection. This is a very fascinating graph that's called the viral cartography. It was published in Science magazine on August the 19th. They put everything into perspective by centering the original viral strain from Wuhan and to see if antigenetically how far or how close they're related to the original strain. So far, beta is the farthest away variant, which means antigenetically it's more different compared to the original strains. Remember, all the current vaccines were pretty much developed based on the original strain. If you have a new variant, it's far away from the original strain. That would tell you it's less likely our current vaccine is going to work on that strain. Did you notice Delta is actually much closerly related to the original strain, which means Delta is probably not that bad in terms of antibody or vaccine evasion. Beta is a whole lot worse. Theoretically, based on this map. Well, does theory always translate into reality? We have to look for data and any publications, any research to see if that's the case. The short answer is yes, that is the case. As early as in March, a study was published in the New England Journal of Medicine. It's an in vitro study using neutralizing antibodies generated by the Pfizer vaccine. Among all these different variants, USW1, that's Washington State #1, that was admitted to our hospital at Everett Providence. So that's considered the baseline. And then you have alpha, you have gamma, you have and the 614G and the receptor binding domain mutation and stuff. The only one that shows significant antibody titer drop is beta. So we should be very, very feel fortunate that the South African strain beta came to our state and did not take off. And Delta pretty much suppressed beta and took over. If beta had taken over, we would have a whole lot more vaccine breakthrough infection that I can imagine based on this study. Well, again, is this study reproducible? Is this confirmed by other studies? The answer is yes. So in July, another study was published in Nature. It came from France. And 8 weeks after the Pfizer vaccination, and you can see beta produced the lowest number of antibody titers. Again, these are log scale, so a little bit of difference on the vertical line is huge difference. So delta is not as good as alpha or the baseline, but still substantially higher than beta. So that cartography map was really, really smart, and it was able to predict which variant is going to do poorly by vaccine protection. I have a third confirmation study, and this one's published in Science about 2 weeks ago. Again, the triangular red is beta plotted out over time up to 209 days. And everything is dropping, which is expected, but the lowest antibody titer neutralization goes against the South African beta strain. So thank God beta strain did not take hold in our country or worldwide. So before we read this article, we already knew based on the data review, we shouldn't panic. The vaccines we have is still working very well for Delta strain variant, but to see a study positively confirming it will make me feel better, because the previous ones were in vitro study. We wanted to see an in vivo study in human and see how that works out. So this, I believe this came from the United Kingdom. They showed the Pfizer vaccine after the second dose against Alpha, the effective efficacy is 93%. Against Delta, it did drop, but not by much, 88%. So not only in vitro neutralization studies show Delta is not that bad, we have human in vivo studies showing there was a little bit of drop of efficacy, but not by much. So don't panic about Delta in terms of your antibody protection from vaccines. And then, so that's the clinical trials, and we have real life data published by CDC in MMR regarding Delta variants. Depending on how many days after vaccination, the protection ranges from 73 to 80%. And this study is a little difficult to interpret because they segregated protection before Delta took hold and after. But during the same time, a lot of lockdown measures have been lifted or relaxed. So a lot of confounding factors. That is, this drop of efficacy is not entirely because of Delta variant, many human factors as well. So the question is, well, perhaps so far we have not run into a bad variant that's escaping antibody protection. But what about in the future? Could there be viral mutations that's going to wipe out our current vaccine at some point? We have to redo the vaccine trials and designs, perhaps possible. So this was a theoretical discussion published in Science back in March. And the problem is we don't know what's the precise level of antibody we need. That will be the protective margin below which we have to generate the new vaccines. It's a scary thought, but it's probably going to happen if the pandemic continues, and many more variants are going to show up, and some of them are going to evade the antibody we generate by vaccine. I'll show one study that was published in Nature in February. Very scary thought. This came from UK. They had a patient who were hospitalized twice from May to August until the patient eventually died. He was hospitalized for a total of, he was sick for a total of about 102 days. And during that time frame, the hospital done a fantastic job. They sequenced his SARS-CoV-2 virus 23 times. So at different time point on the same patient after different treatments. They wanted to see how the virus might mutate. And so they monitored it for a while. After remdesivir, which is supposed to be a wonderful antiviral therapy, by the way, it's not. There was very little change. But after they gave the patient convalescent plasma here and the convalescent plasma here. And soon after the convalescent plasma, what is convalescent plasma? It's antibody generated by other people who survived the COVID-19 infection. So when you give antibody to the patient, the virus mutated. It caused the substitute mutation, and it caused the deletion mutation, and it increased the and it caused the decrease in sensitivity. So it's escaping the antibody protection after the antibody treatment. Scary, right? And also it increased the infectivity. It is scary because treatment, particularly antibody treatment, induced and triggered viral mutation that would survive the antibody. The good thing, the sad thing is the patient died. So this bad strain of virus died with the patient, did not get spread in the community. And what about in vitro studies? Any studies that would show this kind of antibody exposure will cause the virus to mutate and escape? Yes. Another study was published just maybe a week or 10 days ago in the Proceedings of National Academy of Sciences. You know, this is top-notch science journal in the world. What it shows is when the virus is cultured in tissue culture cells over a period of about 100 days. And so the x-axis is the number of days the virus were cultured in cells. You know, the virus you cannot culture by itself. The virus is like a parasite. It has to live inside mammalian cells. So you have to have cells to grow them. And because you have cells, so you have passages. So you have passage 0, passage 8, meaning each time you split the cells, that's called a passage. So by passage number 7 and day 45, there was a deletion mutation happened when you co-culture the virus with convalescent antibody, people who survived the disease and had antibody against the virus. When it's co-cultured after 45 days, the first mutation happened, the protection titer dropped. And then the culture a few more days, by about day 80, another mutation happened. And this time, the antibody from the patient who survived the disease became completely useless. The neutralization titer became 0. And scary, within 100 days, when you expose the antibody to the virus for a long period of time, the virus got so smart and the antibody became useless. So the implication of this study, in my mind, is we have so many people who are vaccinated. If somehow they get sick, and they don't get very sick, they don't die, and the virus in their body might mutate because they're trying to survive your antibody. When that virus mutates, you may spread to the next person because you didn't die and the virus didn't die with you. And so this is a battle between nature and science, and we'll see who wins. But the good news is all pandemic eventually come to an end. No pandemic will go indefinitely. So eventually we'll survive, and eventually it's the antibody and the herd immunity that's going to protect us. So don't get overly panic about this. This is just for academic interest discussion. Okay, so the next issue is how long will the vaccines work, and are we due for a booster shot? And we often hear about Israel. They have all kinds of studies, and I show this time to do a booster shot and stuff. It's actually not easy to find their publications. They often talk about in the news media, but the data is not published, easily searchable. I did find one that was published in a not peer-reviewed journal, medRxiv, 10 days ago. What's interesting is they compared the vaccine-produced antibody duration against natural infection-produced antibody. The top panels after vaccination, oh, here we go. So it's a Pfizer vaccine. And in the first month, the antibody titer is very high, 12,000. The second month, it dropped quite a bit to only 56% level. That's 44% drop in 1 month of of the antibody titer. The next month, it dropped it by another 50%, and another month it dropped it by another 30%. So by the end of 6 months, you only have 6.3% of the antibody level that you started out 6 months ago after the vaccination. That's a dramatic drop of antibody, very, very rapid. And the sample size is not small. It's about 500, 400. And one thing I wanted to point out here, this is not a prospective study. So this is not the same 500 people that's been followed from 1 month to 6 months. It's a cross-sectional study. At this point, how many people already had the vaccine for 6 months? So in that sense, this study is not as a high quality study, but still that gives you an idea. The antibody titer really, really deteriorates, drops fast. 6 months later, you only got 6% antibody left. as compared to people who recover from the natural infection. Their antibody titer were a whole lot lower in the beginning, but they last a whole lot longer. They drop much slower. By the end of 9 months, not 180 days, going out to 270 days, that's 9 months, you still got 38% of the antibody level you had 9 months ago. So what is the difference? Perhaps there's some other components from the virus that would generate some co-immunity that protects you from losing your antibody rapidly. Okay, so this is the antibody titer. And one thing I wanted to point out is the drop of antibody titer does not always translate into the drop of protection. That does not mean by the end of 6 months, 94% of you will be at risk for infection. That's not the case. How do I know? Let's look at the clinical trial. So this is the Pfizer clinical trial. This is actually trial data that monitored their patients out to 6 months. As you may recall, the Pfizer trial, 23,000 in the vaccine group and 23,000 in the placebo group. When they monitored the vaccine out to 2 months, initially 96%. After 2 months, the protection drops to 90%. After 4 months, it drops to 83%. So as you can see, the vaccine efficacy drops, but not proportional and not as dramatic as the antibody titer. The immune system is complicated. It's not entirely mathematical, because there will be T cell immunity, there will be immune memory, and so I don't want you to get so panicky when you look at the drop of antibody titer and translate that automatically into the protection level drop. Well, this is another study from Israel. What it shows is, what I want to point out is the antibody titer does matter. They have 1,500 fully vaccinated healthcare workers, and 39 of them got infected. They got breakthrough infection. So when they had their blood sample collected before they got the infection, they noticed the people who got infected had a lower antibody level as compared to the control, meaning the people who were vaccinated and who were not infected. How much difference? Again, this is a log phase difference, very difficult to tell on the chart. The difference is the people who got breakthrough infection only had 0.361, that is 36% of the control antibody level. So people who got infected only have 1/3 of the antibody level. That means if your antibody level after vaccination is lower, you are at a higher risk for infection. So antibody titer does matter, even though it cannot be mathematically translated proportionally. Well, time for a booster dose. I guess at least that's our White House says so, and I support that. And based on the data I reviewed, again, like I said, a lot of the Israel hypes came from the news media. It's not in published data. This is from an Israel newspaper that talk about 1 million Israelis got the 3rd dose, and after the 3rd dose, they were protected 2.5 times more as compared to those who only got 2 shots. And this is only published in the news media, and not any data I can show. And then initially they were giving the 3rd dose shots to people who were age 50 and above, and now they dropped down to age 40 based on their data. And Israel is a very developed country in their health care system. Sounds like our government trusts their data, and I have no reason to trust their data either. So I think if this is what they're doing, it's probably the right thing to do, not to mention that we reviewed our own data that was published, and not my own data, our own review of data that shows the drop in the breakthrough infection that is happening over time. So I just read this on my cell phone a while ago. I posted here on September 1. That's 3 days ago. Moderna just submitted FDA application to get approval for the booster shot. They enrolled 344 patients, and after the third dose injection, they had a very nice 42-fold increase of antibody, even for Delta. Gamma is lower, beta is the lowest, as we talked about. Theta is the toughest one. And what's interesting is we talked about the dosage difference. Moderna here is talking about, we're going to give half dose for booster shot. Instead of 100 micrograms, we're going to give 50 micrograms, which I think I like this. I really don't like to get sick after vaccine shots or like to get too sick. 30 micrograms is still higher than the Pfizer. And I think if I have a choice, I'll probably go with the Moderna 50 microgram and dose shot. So the other question that I mentioned earlier is, how about mix and matches? This is very important because we have a lot of Chinese friends, who have kids coming to the U.S. for school. They got the Chinese vaccine in China, which is not recognized in the U.S., and they often ask, can I get another vaccine? Can we mix and match? I haven't seen any clinical trials, but I know there are primary care physicians who are friends of mine. They've been giving the messenger RNA vaccines to Chinese students who got the inactive vaccination. They did just fine. I'm pretty sure their antibody went up, even though they were not followed. But there was one published study on July 14th in Nature Medicine. So this was a British study. They gave the British AstraZeneca first dose, and then they compared the boost dose by the AstraZeneca vaccine against the Pfizer vaccine. The Pfizer vaccine boost dose gave 11-fold increase of antibody as compared to AstraZeneca injection. So it looks like it worked well. The side effect profile were very similar and also surprising, but the antibody production was actually much better. If they gave the Moderna vaccine combination, I can imagine the increase of fold will probably be even higher. Okay, last but not least is what about children? Going back, you see all these headlines. One school teacher infected half of the class. One principal told a student to quarantine, and the dad got mad, got two-person going to threaten the principal with zip ties, and we're not vaccinating the kids. And then in Waco, Texas, there were two teachers who died of COVID-19. They had to shut down all the campuses in that school in that school district. This is headline grabbing. It is indeed a problem. How do we grasp the problem? The most reliable source of information came, in my mind, from American Academy of Pediatric and Children's Hospital Association. They kept a very good database from last year to this year, per week, not per day. The highest number weekly child COVID-19 cases were in the summer, about 211, and now it's back up to that level. It's 203 as of August the 26th, and the curve is still going up. To put that into perspective as compared to the adult population, the adults were shown in light blue, children were shown in darker blue. Back in April last year, only 2.6 of all COVID-19 cases were children. And now it's up to 22%. The average is about 14%. So indeed, this is a problem because kids have more social interaction, they have more contact, and they're less careful. And most importantly, they're not vaccinated under age 12. So what's next? I'm borrowing a slide I used earlier in April. I believe what's going to happen is going to be determined by three factors: how the vaccinations will be accepted and implemented, how the viral mutations is going to happen, how our human and government behavior is going to influence the outcome. Here, actually, I wanted to change the vaccination to herd immunity, which actually should be equal to vaccination plus natural infection, because as we know now, the natural infection is producing a significant portion of population immunity. As of May, it's 20%. As time goes by, this curve is flattened because of the vaccination, but in an unvaccinated population, the natural herd immunity will continue to rise. That's it for my talk today.